recording. Okay. Okay, hi everyone. Thanks for coming. And yeah, so we're gonna do this series. I'm gonna introduce Anna. So we were classmates in Cooper, and you want to introduce yourself?
Sure, yeah. Lyng and I studied together, and since then I've been working and living in Germany and now England in architecture and teaching architecture, and also writing projects around architecture. And I'm working on an architectural novel at the moment.
Okay, so I think most of you know me. So I have my own practice and I'm also teaching. And this is kind of like our research and interests, because basically this is how we learn architecture in school. We have our professor doing very deep research all the way till they are 90 years old. They're always researching and learning about new projects, and they can talk about buildings for hours, right? And it's quite in-depth. So I don't know, then after graduation I find myself liking to do this, and I think Anna as well. So we are like, why not? This project is like 5 years late. We are like, why not? Let's just share the first building and see how it goes, right? So this will be the and first project that we are going to look at, and basically, um, I mean, we are influenced by Peter Eisenman, and he wrote this book on the 10 canonical buildings, right? Basically, trying to pick 10 buildings that define the discipline of architecture for him, right? So, with this concept in mind, and then I'm thinking, like, what are the 10 buildings that's most important to me, right? So I've been collecting this list of 10 buildings, and Einstein's theory is one of the Einstein's tomb is one of the project that I picked and is on my list. And the reason why I picked this project is because it's a highly conceptual project. It's never meant to be built. It's like it exists in the outer space. So there's this question um about architecture, right? The role of architecture, that is not just to solve problems on Earth, but um, it's like the blue sky inquiry, right? Like why we go into space and go look at the moon and stars and universe beyond, right? So it's not just about the building or the physical thing. It's not solving poverty problem, right? But it's to find out more into inquiry and go into the unknown. So for me, that's like the best potential of architecture, right? That it doesn't have to be a built project. And so this project is by Lebbeus, and you can see his drawings are somewhat like that. He doesn't build a lot, but they're all conceptual projects. Basically, he's very interested in experimental space, and in one of the lectures, he said these are the spaces in which you don't already know how to behave. So the example that he gave is like, well, if I name this space like classroom, or is made like four walls with chairs and blackboard, right? Then you will kind of know how to behave. So his definition of experimental space is like spaces that you don't know what it's for, and you don't really know how to be yourself in that kind of space, right? So exactly in this spirit, right, that he designed Einstein's tomb, right? So you can read his blog as well, right? So to him, this is also the task of an architect, right, to take us to places and spaces that we have never been before, right? So this is equivalent in science, like the exploration of the outer space.
Yeah. So like Lyng was saying, I think we've both been excited to look in depth at some building works, and hopefully some more after this one. Many years ago, let's say like 2017, she asked me also to make a list of canonical works, and I duly gave her a bunch of literature and philosophy books instead of architecture. project. So I'm still working on my 10 canonical works. And what I like about Ling's interpretation of that is that, I mean, right now, I think at least in Europe and in the United States, there's a lot of pushback on the idea of the canon and on the sort of overarchingly male view of how we teach history. But if you look at what Eisenman says, and then what Ling's working out of that, is that we can each create our own history out of which we define a set of tools and then work with them. So I want to read a bit of something from Woods on the left here. I won't actually read the entire thing. Let's start at the beginning. So loss is inevitable in the story of each person. Losing your wallet, losing your job, losing your home, your family, your city. The degree of loss escalates from the inconvenient to the inconceivable, and with it, the experience of the ineffable. Loss, however, is necessary in order for us to change, not only in our habits, but also in our understanding and beliefs. As long as we cling comfortably to what we are and know, we cannot learn or create. If design is to be a creative act, it must take on the most difficult situations in our lives. It must offer more than comfort and reassurance. It must confront the unspeakable, the ineffable, and become a means by which we can transcend it. This means that we, as individuals and as architects, must, as the existential poet Nikos Kazantzakis once put it, build the affirmative structure of our lives over an abyss of nothingness. A heroic, possibly too heroic task, it's true, except for those of us who have no choice. So I think as we get into this project, you'll see why this quote relates to Einstein's tomb, not only in the problem of death and memory related to someone that's now no longer with us and how to think about that, but also what the role of creativity is in relationship to something versus nothing or emptiness, and the existential question of like how we build meaning. So we're going to definitely move through all kinds of different conversations in Einstein's tomb, from the philosophical to the scientific to the architectural, and yeah, I'm excited about that.
Okay, so I think we are going to go through the original drawings and text of the project first, and then we'll go into the analysis. So this project was published in the 1980, and in this pamphlet architecture, they exist as individual publication. Each publication, one project for each publication. So you can see here, this project is in Einstein's tomb, number 6 in the first series. So this was the end. I think Louis Kahn had just passed away, and then you have the new American architects coming up, right? And they are trying to form like a new voice or new theory for the era. So we have Peter Eisenman, Kenneth Frampton, and Genderson, right? So this project was published in pamphlet architecture, and this is the original text and images, which Anna will read to you.
Great. So we've got a few pages of text. It probably would take me a bit over 5 minutes to read through, so you get a clear understanding of what Lebbeus Woods was thinking for Einstein's tomb. And they're written sort of in a verse and put next to several line images or prints of his work. So I'll just get started. Einstein tomb, Lebbeus Woods, 1980. Newton and Descartes considered time a neutral product of relationships between energy and matter, or a condition essentially independent of them. Their time was a linear field of infinite extension, described by regular increments. Accordingly, their universe was not only eternal, but also of infinite measure. Einstein, however, conceived of a new time, one interdependent with the mechanics of motion and materiality. His is a time of transparency and elasticity, a subtle and complex interval and modulation, a forceful active time that colors and shapes events. His universe is a warp of finite duration and boundary, yet of infinite renewal and continuity. The form of the Einsteinian universe is related to the most ancient symbol of the cosmos, the circle, Mandala, set in motion by time to create the epicycles of day, month, year, and millennium. As the Mandala symbol presages the effect of relativity, so Einstein's thought bears into the modern world ancient wisdom regarding the unity of nature, the oneness of all things. His quest for a unified field theory was an attempt to give new meaning to the ancient dream of totality. In this way, he advanced beyond the boundaries of pure reason, bringing Western philosophy and science nearer to the synthetical realms of Pythagoras, Heraclitus, and the mystics of the Kabbalah. After his death, Einstein's body was cremated and scattered over the Atlantic Ocean. Has conceived a tomb. His tomb, if it is to house his remains, must not only honor his memory, but also embody his ideals. And next to this set of text, Lebbeus Woods has drawn like a cruciform cross shape with several circles around it, showing that it's rotating in different directions and intersected by planes along the axes of the cross, and then also inhabited or extended in various directions by a sort of urban-like composition of sculptural forms. And the text continues, the tomb is a vessel journeying outward on a beam of light emitted from Earth, following an immense and subtle arc through the stars. For eons, it will inhabit the dominions of space until a distant time, it must return to the world of its beginning. Thus, the epicycle of space and time will close. On that remotest day, the dark corridors of the infinite will again become thresholds for departure, fading shores on the dark gulf of eternity. The form of the tomb has always been known. It exists as a sign in ancient codices on countless ritual maps of exploration. The tomb has always existed. So, and on this page, he's got some diagrams of the cross with some circles around it and notes, and a very beautiful dark perspective drawing of this sculptural architecture, like flying through space as the image that goes along with it. And then he has some more images that are both like sketch-like preparatory drawings of the architecture moving through space, and another more finished, almost like etching-like drawing with some stars in the background as the beam of light shoots through the cruciform. Back in the text, Lebbeus writes, as a symbol, founding religions and philosophies, it echoes the form of Earth, whose four quarters are known as dawn, day, dusk, and night, as spring, summer, autumn, and winter, the second and fourth quarters being transitions, fulcrum points between two pure states of light and darkness, birth, death, ascent, and descent. Yet, these two pure states, the first and the third, are but fusions of these former two transitions. Day exists as a union of dawn and dusk, gathering of ephemeral light into incandescent wholeness. Winter is a silence, a calm between the pure and clamorous moments of birth and dying, of fertile spring and the sterile autumn. And here he's got more diagrams and images of outer space with the architecture flying through it. In the same way, the humanity and suffering of a man, we may call him Einstein, are an apotheosis of passion and coldness. The life of a man is driven between extremes, between dim and vast regions of imaginative thought, and the more narrow, bright, and lucid ones of wisdom, at one moment elevated by heroic vision, at yet another turned upside down, mockingly self-conscious, now finding harmony and light, now dissonance, decay, and darkness, until the cycle of a life is woven wholly into immortal ones of the world. So it was with Einstein. In his life, he was compassionate and loving, an active champion of humanist values. In the arcane language of his work, he was a poet possessed by revelation, isolated from others by an elusive and awesome vision. As finite reduction, so it was with this vessel, this tomb containing nothing, wandering on a random pulse of light, has always existed. Tomorrow or the day after tomorrow, it will appear among the fixed and stable constellations of night. Even now it approaches from limitless possibility. All random journeys, all the immortal corridors begin and end in the vaulted space of Earth's night, under the vagrant light of stars. And the last two images that Lebbeus has, one is from one side of the cruciform showing a sort of daylight image, and the last image is the urban agglomeration of objects that is set onto this cruciform from the nighttime or from the dark position in outer space. So that's giving you guys all the full project now, as far as we could find it, all of the original drawings and text that went along with it.
So, okay, 30 years later, and then on his blog, Lebbeus wrote about this project again, but these are more lengthy paragraphs describing the same thing. So in terms of text, there's not so much new information, but he did have this series of drawings of the launch of the tomb into space. So the launch, you can see here on the top left-hand corner, where you have the sun, the moon, and the earth all line up together. And then you have the silhouette of the tomb floating or emerging from the right, and then slowly orbiting. And then there's a beam of light at the end where it shoots through the center of the cross, right, which is the tomb. And then he has this other image, right, that the image of the earth, and then a clearer picture of the cross with all the figures on the cross. But the center of the cross is actually a void, right? And you have all the, like a Hubble space image of the universe in the background. So this is also something new. And then we also found this model of the tomb with the San Francisco MoMA. So it's a model by Alexandra Wagner. We are not sure when this was made, but it was made in metal, but it wasn't floating. It's kind of like resting on a base. Right? Okay, so that this is the end of all the original information that we can find on the project. We'll now go into the analysis. I guess the first part, like in the opening paragraph, he talks a lot about the Newton space, the Newton's concept of time versus Einstein's concept of time, right? So I think there is a lot of so when we were studying this project, I think the first question was like, what were the differences in terms of time, right? And how time and space, right? So, and how has science, the concept of science and all this influence architecture, right? So if we go through in the prehistoric time, I think so we want to examine the relationship between science and architecture. So before Aristotle in the 6th to 5th BC, the concept or the vision of the universe is a flat earth. And then you move to Aristotle in the 300s BC, and they start to think of a spherical earth, right? And I think around the same time, Pythagoras or Plato, they also mention a little bit about this spherical earth theory. And then finally, all the way to uh, when you go to Ptolemy, which is around 100 to 170 AD, so we start to have the idea of the earth being the center of the universe. So this is a geocentric view of the world. And the drawing on the right is the depiction of the world uh, surrounded by different planets, right? And then the next step is the Copernicus, right, proposing the sun being the center of the universe and Earth is just orbiting around the sun. And then just slightly before that, there's the invention of the press, Gutenberg press. So that why that is important is because um, you can see the next stage, right, where you have Galileo, Borromini, and Kepler. One in Galileo in Pisa, Borromini in Rome, and Kepler in Stuttgart, and then Copernicus, of course, in Poland. But all these ideas, they know about all these ideas because of the press, right? Before the invention of the press, information doesn't spread so fast, right? So moving there, like going to Galileo and Kepler, they start to look at elliptical orbits and they start to think about uh, kinet kinematics, like moving things, or they have telescope, the invention of telescope, right? So all of a sudden, it's no longer just a theory. They are actually able to see all these planets and all this moving, right? So the Galileo and Kepler's all this idea, they also kind of start to impact architecture because before Borromini, you can see like all the classical architecture, you have a perfect circle or a more like a fixed shape where there's not much movement, like because the center is fixed and everything is kind of like definite, right? But when you have in Borromini San Carlo, for example, you start to have the double circle, but these two circles they start to form an ellipse, right? And when you have double center, there's a lot of uh, movement is implied, right? So all and then you have all this ellipse being the orbit and things like that, right? We can't really say okay this influenced this, but the whole awareness of the time is changing, is slowly changing, and science and architecture is definitely quite tied together. And then the next step, we have the Newton's theory, right? So the three laws of Newton and how all these masses, the bigger you are, the bigger the gravity force, right? And there's a definite center and it's based on attraction. So in Newton's theory was invented in the 1600s to 1700s. And then you have Boole in the building the cenotaph for Newton, right, in 1784. And you can see on the right, this is a cenotaph. Uh, we are, I mean, after studying, I don't know how related this cenotaph is to to the law of Newton, but then it's definitely we are back to some sort of like a finite world, like an absolute circle, and something like this. I don't know, you enter and you can actually stand at the bottom of this whole sphere, and then in the day you will see like it's dark inside with stars, and then it's the reverse when it's nighttime, and then the inside will be lit, right? So I think after some research, we don't find a lot of relations between Newton's theory and Boole's cenotaph in that sense, right? So from Newton's theory, then we move to Einstein's general relativity theory, right, where there's no gravitational force, but it's more like a space-time warp around. So all these objects, they move around a bigger mass because the whole time-space is being warped by the bigger mass, right? So because of all this theory, and there's also the static universe and cosmological constant that Einstein talked about, but abandoned in 1929. But it's pretty much what Lebbeus' understanding of Einstein's theory is, and this we will elaborate a little bit more later. But as for now, this is the development of and the relationship between science and architecture that we can find.
Yeah, so just to maybe get a little bit more to grips with this difference between what Woods was pointing out at the very beginning of his project is the difference between like Newtonian gravity and general relativity. So Newton said that like massive objects attract each other. So the more massive an object is, the more it will pull other objects towards it. So that is the gravity that's displayed on the upper portion of that slide. Whereas what Einstein realized is that it's not just that the objects attract each other, it's that the space-time fabric is warped around depending on how massive an object is, and that's what causes the variations in the way that orbits and gravity can work. And that applies not only to objects, but also to light, right? So that's where part of what will get very interesting. So Einstein used some of these ideas around his theories around gravity to try to extrapolate towards an overall unified theory for the entire universe. And while what Lyng was just saying, that he, at the time, it was generally accepted that the universe would be static and finite. So that would be like on the very left, maybe a spherical universe. And if that were true, then basically you wouldn't have any of these diagrams happening. But since then there are other ideas that maybe there's something like the universe existed, like came into existence with the Big Bang, and then it will eventually end in a big crunch, or that it's slightly expanding, or that it like has an accelerated expansion. So I'm going to kind of get into the problems of that also later on, but we actually don't know what the shape of the universe is to this day. There was a period where, like I said, Einstein thought it was static. Then people have thought that it's expanding. Then they thought that it's accelerating in its expansion. But there are also theories that it might go through a big crunch in the future. So this is a bit unclear. So after looking at the, can you go back up? Yeah. So after Lebbeus is looking at the sciences, he makes the comparison to the sort of Einsteinian ideas of the universe that's like flexible and subtle and elastic, and the way that the space around things is modulated. And he relates that to ancient cultures and symbols, in particular to the Mandala. And on the next page, he also then talks about, in particular, a few other philosophers like Pythagoras, Heraclitus, and the Kabbalah in relationship to his unified field theory, stating that the modern world and ancient wisdom regarding the unity of nature and the oneness of all things. So Woods is convinced that Einstein is looking, or Einstein has a relationship to more ancient ideas. So I just want to kind of give you all something that Woods must have been looking at when he's developing this project, would be these symbols of the mandala, particularly in the Hindu and the Buddhist versions. As you can see, they have a sort of connection between the cruciform and the circular like composition involved in them, and they are generally like having these four gates on the top, bottom, left, and right of the mandala that suggest basically, if when you look into it, the point of the mandala is to create a map of a unified mind, so of the human and of the cosmos, to suggest that at every single scale there's a unity of forces and maybe rules or laws, and that there's an inner and outer synthesis of what's inside beings and out in the cosmos, and that this mandala represents a symbol of all of those cosmic truths. And at the center of the mandala is also like the abode or the house of the deity. And so those 4 points on are gates towards a house, which is the like nature of the empty and enlightened mind in Buddhism, and it is like a tool to aid in their like meditation and trance. And at the same time that it's like a sort of quasi metaphor for a physical space, it's also a sort of calendar with the sun or the earth and the cardinal directions integrated into all of that. So there's so many different like overlaid meanings in the mandala, but I think what's interesting is how well that correlates to the very simple and abstract form that Woods ends up taking out of it, which is like a cruciform that's like rotating through space. And then on the next slide, I've just kind of briefly given some images for Pythagoras, Heraclitus, and a bit about the Kabbalah, which he references, which I guess compared to the mandala, which is more from Eastern cultures, these references are a little bit are more from the Greek, and then from the Western culture of like sort of ancient Jewish theology. So some of the ancient Greeks basically have this understanding that the universe is mathematical. So that's like where I think Pythagoras and Einstein correlate in Woods's mind. Whereas Heraclitus especially was interested in cyclical stability. So they are very much trying to propose non-duality, where you have the up and the down. For every up there's a down, and for every like anger there is harmony, and that a continual circular exchange of motion actually ends up creating stability. So that will also like come back to with the epicycles and cycles that Woods is proposing for his project. But Heraclitus is definitely like one of the sources of inspiration for thinking about this philosophical term of non-duality is like quite fascinating. And then the Kabbalah, which he references, has a paradox like at its center about the creation of Earth and the universe, which is, and I have full disclaimer, I'm not like a scholar of any of these things. We've just been researching this for this project. So my understanding is that in the Kabbalah, there's an idea of the withdrawal of God to make an empty space in order for creation to appear. So the relationship between like void and creation, and the beginning of creation requiring an action of withdrawal, is quite fascinating in relationship to both the mandala idea, which also has the idea of the empty mind at its center, and Lebbeus's cruciform, which also ends up being void at its center.
I think also in the Egyptian culture, Mayan and Chinese as well, right? There's a lot of not so much mandala, but in terms of cosmology and using the astronomy to determine the facing or the axis or the direction of the important architecture, right? Like palaces or tomb, right? So they are likely to align to some important stars for that particular culture. So this is quite common in different civilizations. The next, I think now we are looking at the whole trajectory and the launch of this tomb because it's not supposed to be stationed at one place, right? And then so it's riding on a beam of light, so it's traveling on a beam of light, but it's also rotating on its own, and then it will go through the emptiness of the universe and somehow return to the world in the end, right? So this is the part that I think we tried for very long to try to understand, like why does this have anything to do with Einstein's theory? Why is the tomb returning, right? Why would this light return? Is it because the universe is warped? So any light that travels into space will return eventually. So first of all, then we try to break down all this in different steps. So the first one is riding this beam of light, and uh, so we found this interesting. Um, I don't know if it's true, but apparently since 16 years old, Einstein has been wondering what it would be like riding on a beam of light, and what would you see? Because would you see anything? Because now we are faster than light, but the fact that we see most of the thing in this world is because of light, right? So now you are faster. Are you going to see complete darkness or warp images or colors? Like what is it, right? Uh, do you want to say something about the expect?
Oh, I guess I also wrote on here this German word for Gedankenexperiment, which is just the idea of the thought experiment. And a lot of Einstein's work revolved on the idea of just imagination and constantly questioning what would be possible in order to create his theories. So when he asked like what it's like to ride on a beam of light, that led him to question and think about like if it's possible to be faster or if there's a limit to speed, and like how is light affected by massive objects and things like that.
Right. Then and then the launch, of course. So the three planets line up, the sun, the moon, and the earth. So to me, I don't know, I read it as a tribute to Newton. So you start from where Newton ended, right? Where this tree, the gravitational force is lined up or strongest, and then Einstein's tomb appear or is launched. It's not clear where it's launched, like whether it's coming from the back or the side, but this silhouette of the tomb actually appears, right? And then this is where the trajectory starts. Uh, and then I'm also looking at the trajectory, like so, and then where do you go? Like what is it following some sort of ellipse or what trajectory? So that part is also not clear, right? So in some draw we see that the light is piercing. He writes that the light is piercing through the tomb, but you are also traveling along this trajectory, right? So there's like it's like a planet. So there's like epicycle, and then there's a bigger orbit of the planet. So, but what is the orbit? It's not so clear. But these are the images that we see. So this looks like it's near the launch, and then uh so this is the question of why would this tomb come back eventually? And for that we have to look at the shape of the universe again, and that Anna has mentioned in the beginning. So these are
Right.
you can go for
Right.
it.
So if you had the spherical universe at the top and you
You,
shot a light beam, possibly then the light beam would just go around the sphere and eventually come back, right? On the other two shapes, they would not come back because they're either open or flat and they end up shooting off in various different directions. So we have like a saddle shape or a flat universe. I think what's interesting to think about, as I mentioned before, was that when Einstein went and tried to extrapolate his ideas around the theory of relativity to the universe, he found equations that worked to describe the physics he observed or theorized, but they always suggested a dynamic universe. And so he ended up creating a fix. He ended up suggesting something called the cosmological constant, Einstein's cosmological constant, in order to make the universe stay at a constant shape at this point. And maybe 15 or not that much longer later, Hubble and other scientists, they began to have observations that the universe really was expanding. They were seeing redshifts and stars showing that they would be moving further away. And that meant that Einstein basically reevaluated his calculations and his formulas to reflect a expansion of the universe, and he took that cosmological constant back away so that the universe could expand. So if you had a static universe, as Einstein originally suggested, maybe you would have this light beam return, as Woods has been suggesting in his project. But with the expanded universe, we're not really sure how that relates to Woods's proposal, although we don't think that Woods was being cynical or anything. I think he was attracted to the idea of the two possibilities of the ancient and the Einsteinian ideas coming together. A third idea is the one of the Big Bang and the Big Crunch, in which basically the world begins to exist in a sort of expansive way, and eventually the density and gravity in the universe requires it to fall back in on itself and to crunch together. And that would be even more like what Woods is suggesting, that all light at the beginning of time, eventually, as it's shot out in different moments, has to come back to its original spot, which is the original spot of everything. And then it would go in these cycles of being in existence and out of existence. So again, as we've mentioned several times, we're not really sure where Lebbeus is latching on to these discussions around physics, but he's found one that fits with a resonance into the Kabbalah, into the Greek ideas of non-duality, and like where everything that has nothingness also has something, and then also the ideas in Eastern philosophy of Buddhism and Hinduism. So I think he's basically trying to synthesize so many things that the science may or may not be true to the Einsteinian understanding at the time.
Yeah, so I think he's more interested in things like that, like day and night, the cycle of day and night, and the idea of epicycle, where uh, there's movement. There's also mini orbits around the big orbits, right? And all this is like this defines day, night, um, spring, summer, autumn, and winter, right? So the other thing that we look at is like there's this figures that's sitting on the or protruding from the cross, and yep, maybe Anna.
Yeah, so we're kind of like wondering, why is Lebbeus putting these like urban forms on just two of the like extrusions of the cross-like axis? Why aren't they on all four sides, or why isn't it just on one side? What's going on with this architecture that he's created, and what are these objects there? So he does reference them later in his blog as being kind of city-like. And what we began to see in them was basically this so also a correlation to some of the drawings he was making to day and night. So in the previous slide, he also has two drawings, one where the sculptures and the urban light form on top of the cruciform is lit up by and is a little bit more, is rendered as if the sun is shining on it, and then the other one is rendered as if it's in darkness. And so I think like his interest in non-duality and the fact that life only exists because death exists, which is a sort of representation on the right hand side of this slide, where in order for there to be summer, there must be also winter, and in order for there to be all of these dualistic aspects of our world, they require each other and their transitions and their gradients all to exist together. So the world is like inherently paradoxical and like moving in transition between these phases. So I think that's like where we came with, and I think that's something Lebbeus then also explored in this project, just as an aside, the Berlin Underground, where he worked with creating a city like almost completely submerged under Berlin as a way to explore that experimental space that Lyng brought up at the very beginning of the talk.
I think then we move on to the shape of the tomb, and I mean he talks about here as a sign, but is it a cross or is it two minuses, right? So I think there are a few ways that we can read the sign or the symbol of a cross, which is quite loaded because there is the through history, right? So it's always a very symbolic symbol.
Right. So he says, you can see in the bottom where it's underlined in this text from his blog, that it's not a religious symbol, but instead it's more a plus sign that's formed by the intersection of two minus signs. So if you think of a plus, that's one thing, but if you take two minus signs as an emptying idea and another emptying idea, then at the center of that would be a massless idea, or the void. So the only way for something to be as fast as the speed of light, according to Einsteinian theory, would also require it to be massless. So there's a paradox in what Lebbeus suggests here, which seems like a built thing, but it would have to have zero mass in order to be moving at the speed of light as well. And this idea of the cross, like, very much relates to some of the beginning ideas of architecture for urban planning in like the Roman city ideas. So probably some of you guys have come across the idea of the Cardo and Decumanus as the planning tools for Roman military bases, but also Roman cities. So all over Europe, most cities have some central cross which defines a grid, and close to the central cross will be a void, like the forum, or in our case with Einstein's tomb, you have the cross and the void at the center, which would be a sort of forum out of which the tomb of the Einstein tomb is based. And then there's a few more symbols I guess we wanted to bring up that relate to this entire investigation. The some of those urban like extensions on the on the cruciform are kind of reminiscent to the decorations on top of gates. So that also has a wider metaphor to the mandala gates. And in that like set of sculptures, there seem to be even figures that look like horses, or even a Pegasus, which then would relate back to some of the Greek references that Woods brought up, because the Pegasus in Greek mythology was instructed by Zeus to bring lightning and thunder from Olympus. So there's actually quite a few more like layers where Woods is trying to bring different symbols together towards the like memorialization of Einstein.
So yeah, I think I think we're coming and to the end of the analysis, but I think basically is the project is a lot about space, time, and light, and that is quite uh surprising, because not surprising, but I think that's the three things that really brought science and architecture together, right? The fundamentally architecture and science, they are both about space, time, and light. And then for this project, at first, I don't know, I thought it's a really conceptual project and abstract, but again, when we look at it, there are like all these figures and symbols, right, that uh they are quite loaded and not very easy symbols, right? And then so in that sense, it's quite fascinating. Uh, so I think to uh you see how at the end, right? So this vessel is not supposed to contain anything, and then it's wandering through space on a random pulse of light, and then reappear. It will appear among the fixed and stable constellation of night, and again return again and again. So I mean, as a project, this is really an I don't know, the project actually opens up more questions than answering uh that rather than answering questions, or and then it's also not solving any problem. It's kind of like it's moving, but compared to the Newton's cenotaph, which is like such a fixed thing. So I don't know, this is like the uh next era of architecture, I don't know, but then somehow it's also responding to the finite universe. I don't know, maybe it's like now, like if we were to do another project that is based on Einstein's theory, I think it would be quite different. Like the take on this will be quite different.
Right. But at the same time, it's I mean, such a gift to have the text from Woods and all of his references, and see how the like layers of meaning come through in such a simple suggestion. It's not like he had to build an entire city. He had to build like a cruciform with the suggestions of inhabitation. And yeah, I think it's a really beautiful project. But now we have been going on for about an hour to get through all of this, which shows just how fascinated Lyng and I became looking at it. But I think we're also happy to, I don't know,
Yeah,
if there's any questions, or if anyone else has comments, or if they saw something that we didn't see and want to chime in, would be delighted to talk to you guys about this.
yeah. So, any questions?
Hi, Sai, and I just want to say thank you for putting this together. I'm driving at the moment, so I don't think it's a very good time for me to ask anything. But if it's recorded, so I suppose you are going to put it up, right?
Yeah,
somewhere.
this
Yeah,
we'll
that we
put it
can
up
go back
on.
and really look at it again. I think it's really is an interesting, is a very interesting and detailed investigation, and different. I think the different takes on how you see the world is formed under different, I would say, perspective. That's really pretty useful. I thought it would be really good for the student to start looking at this as well. So if you can put it up, I think it would be good that you can drive them um, to see, or to rather revisit this talk. Yeah, that would be great. Yeah, sorry,
Yeah,
I have to drive
we'll
now.
put it
It's
up
it's red
on,
light.
we'll put it up on the YouTube channel, and then I think, yeah. So I don't know, guys.
Yeah, that would be great.
Any questions or anything you want to ask? Right. So we hope to actually wanted to do this in like 20 minutes to 30 minutes, but I don't know. I think it's quite hard because yeah, already like going through the original drawings, but yeah, I think we want to do something a bit more detailed than skimming through the project. But yeah, so if no question, or you can ask us anytime on IG or anything. Okay, so I think need some time to digest.
Yeah, thanks everyone for being here to take a listen and be interested in this project and our analysis.
Maybe I have one question.
Yeah,
I'm
sure.
just wondering because both of you have obviously have taken a long time to go through this and have studied it for quite a long time. I was wondering, what have you learned from this, from the analysis of Lebbeus' work that you have managed to use in your own practice? How has that affected the way you practice? And that's what I'm wondering.
Well, Siling, it was on your list of 10. So yeah, first.
Well, is to keep me from being too practical, because when you practice, everything, most of your task is problem solving, and that is really not the full potential of architecture. So this project taught me how to question with a project instead of trying to provide a solution, right? And then is also highly conceptual, right? So how far can we imagine and think, right? And then uh I mean, it's free, and you choose Einstein, right? The tomb doesn't he didn't build a tomb that's like on earth and is meant to be built, right? So this is quite, so not in terms of obviously, my takeaway is not from the information or things like that. I mean, I learned a lot about science. There's like a lot more, because we were like, it really, we took a long time to decipher why lie, and what is what, which part of it is the science, right? How, but then, and then we went one big round, and then only to conclude that maybe wood woods didn't care too much about science, right? But yeah, but so it's a very important project. That architecture project can be like that. It can be about ideas, it can be about concept, right? That is, it's not just uh I don't know, mortar and concrete and practicality, right? That I think a lot of architects can do, but not every architect can imagine and dream, right? So if you want, this is like the scientists in science, right? You have blue sky experiment. There are experiments that solve problem like, oh, can we have a more efficient air con and things like that, right? But they are just scientists that ask questions like, why is the sky blue, right? So it's not immediately applicable. It's like, why do we want to go to the moon? Why do we want to go to Mars? Don't we have enough problems on Earth already? Right? So these are, why do we want to have another telescope in the world, in the space, right? We have Hubble, and then now we have JW telescope, right? Why do we want to know? So I think it's quite hard. especially in Singapore, right? It's like when everything is so practical. So isn't it, this project always reminds me that there's this best potential for architecture, right? That is about thoughts and ideal.
Yeah. I mean, I think for me, it's similar. Like, if architecture has the capacity to be an art form that can either manifest our, like, what's happening in our current era, like, to ask yourself or ask myself, what is the like current experience of life? What is that ideology? What is that like political stance, or like what is necessary to respond to what's going on in the world right now? Or like, how can I be discursive with questions from the outside? So what like is really fun about this project is when Einstein asks, like when he's 16, what would it be like to ride a beam of light? And Woods is able to respond with an architecture. Okay, in order to ride a beam of light, you need a massless architecture. Like, and I'm going to give you a massless architecture as the monument to your life. And what would a massless architecture need? And then he looks into like all of the architectural and philosophical ideas of like mass and emptiness, and finds the mandala and finds these non-dualistic ideas that like begin to layer up all of these answers to Einstein's question of like, what would it mean to ride a beam of light? And I think that dialogistic method for architecture is really productive, because it creates unknown spaces that give you a new sense of what architecture can do.
And there's
Thank you for that. I think very interesting breakdown. And also very interesting takeaways from this so far. Yeah.
so I mean Lebbeus was our tutor in our 4th year, I think. So yeah, he taught us a lot, right? That this is what architecture can be. It's not just about the buildings itself, right? But it's really about ideas, right? And so I find like this is like poetry and music. I don't know. It's an art form. It's not something very practical, right? But through study, we studied this project for what, 3 4 months. And I think, yeah, just it brought me to a lot of science that I don't know, didn't pay attention in school. But and then you are like, you start to link things, and then it's just very amazing, right? So even just for that, I have to thank Lebbeus for the project, because to bring me to all these places, right? All these questions.
And I think it actually is a really practical project because if you go to the quote that I was reading to you guys at the beginning, he's talking about the problem of loss, right? And everyone's experiencing loss in their life. He talks about the loss of a wallet or the loss of a city, and that architecture has the potential to like build over loss and to confront things that aren't comfortable. And if we can use like our work to confront the void of existence, of the void of like having to leave things behind, of things changing, and find ways to do the new, then that's a practical thing that we all need in our lives.
Yep. So I think we both agree like to do this project as the first project, because it's really not so clear cut, like not a practical project, but very fascinating project, right? And you ask, yeah, like what for what, right? Do this project, it can't even be built, but now maybe it can be built, right? Maybe you can propose to Elon Musk and it will be built.
Some versions of it could be shot off into space.
I know, right? So who knows? But it's, yeah. So okay. Any other questions? Okay. If not, yeah. Thank you, guys. Merry
Thanks,
Christmas. Have a good holiday. We'll end here.
Yeah, we'll see you in the new year with another analysis eventually.
Yeah. 4 months later. Okay. Thank you. See you. Oops.